All right, you're welcome to this live class, CSC 280.1, which is, of course, Modern Fortran. And this is a preparatory class for the forthcoming exams on um, computer programming, which happens to be the major focus of this course. All right, so basically, we are to be treating a couple of areas which are very, very crucial to the course. And the areas that are crucial to the course is formula translation, we have algorithms, we have flowchart diagrams, we have control structures, we have input and output statements, we have also the arrays, okay, and of course, how to write simple Fortran programs. Okay, so those are the major contents, okay, or components of the course. All right, so we'll be delving into formula translation. All right, but if you can hear me, can I see a response? Can you just type I can hear you in the comment box so we can proceed? All right, if you've not subscribed to this channel, do well to hit the subscribe button and subscribe to the channel. Okay, if you can hear me, say I can hear you. Type in the comment box I can hear you. All right, I'll be waiting for your responses. If you can hear me, say I can hear you in the comment box. Type I can hear you in the comment box. Okay, I can see one response. If you can hear me, say I can hear you. Type I can hear you in the comment box that you can hear me so we can proceed. I need more responses. I need more responses. More responses. If you can hear me, say I can hear you. Type I can hear you. I need more responses so we can proceed. Like I said, if you've not subscribed to this channel, do well to hit the subscribe button right away and subscribe. Okay, I can see another response. Keep the responses coming. I need to be sure that everyone can hear me clearly. So we can proceed with immediate effect. All right, good. Keep the responses coming. All right, so I think we'll be okay to actually proceed like this. All right, so like I said, we'll be starting with formula translation. Now this course is modern Fortran. All right, modern Fortran, as you can see, modern Fortran, and the term Fortran is an acronym. The term, when we say Fortran, this is actually an acronym that means formula translation. Formula translation. This is what it stands for. Formula translation. All right. So basically, when you say formula, if you think of the formula in physics, chemistry, okay, especially physics, which is known to have lots of formulas. For instance, now you want to write the formula for force. Force is equal to mass times what? Acceleration. Force is mass times acceleration, right? We can all relate to this. Okay, so now if you look at formulas, you realize that all formulas have an equal to sign, right? All formulas have an equal to sign. That's what makes a formula a formula. So the formula is an expression that have an equality sign. They have an equality sign that is used to actually solve a given problem. It can be a mathematical problem, it can be a problem in physics, it can be a problem in chemistry, it can be a problem in economics, it can be a problem in accounting. All right, so formula cannot be a formula if it does not have an equality sign. All right, so formula translation is the full term that describes Fortran. This four you're seeing here is for formula, while this tran you're seeing here is for translation. All right, so it's a concept that you have to understand. It's a concept that you must take cognizance of. All right, so to translate an expression or formula, okay, into Fortran, that is to translate this expression, that is to translate the formula into Fortran. That's what formula translation talks about. All right, so to translate a formula, that is formula translation, into what the computer can actually understand. All right, we have what we call operators. We use what we call operators. All right, so these operators actually helps us to translate formulas regardless of how the formula is. Okay, so they translate the formula into an understandable expression. And it's an expression that the computer, because we are translating this formula for the computer to understand, so it's a formula that the computer will be able to understand. That is the aim, that is the target. That's the target. All right, so an operator, what is an operator? Okay, an operator, like I said, is a tool which is used to translate a formula into an understandable expression. A tool which is used to translate a formula into an understandable expression. All right, so basically there are different classes of operators. All right, but the common and the most recognized classification of operators is actually subdivided into two. All right, we have what we call the arithmetic operators, and we also have what we call the logical operators. All right, so we have arithmetical operators or arithmetic operators, then we have the logical operators. So these are the two classes of operators, or two types of operators. All right, so basically we'll be looking at the arithmetic operators. That's what we'll be starting with. So we'll be starting with arithmetic operators. That's what we'll be starting with. All right, so basically when we look at arithmetic operators, it's important to know that there are 6 in number. There are 6 arithmetic operators. All right, so I'll be writing them. So I'll be writing the 6 arithmetic operators. All right, so I'll write operators here, then I'll write the actions that they perform. Operators and their actions. Okay, so now first operator sign is these brackets. All right, so these brackets. Second operator sign is like this, like asterisk. All right, asterisk, double asterisk. This one is for exponentiation. Exponentiation, that is exponential. Okay, the third operator is division, that is slash. As you can see, the slash sign is used for division. Slash is used for division. Then we also have just one asterisk. This one is different from this one that is 2. One asterisk. This one is used for multiplication. Okay, then we have the addition. Okay, then we also have the subtraction, which we know as minus. We have subtraction. All right, so these are the arithmetic operators. These are the different arithmetic operators. So we usually use an acronym. We usually use an acronym called BEDMAS. To state these arithmetic operators. So B is for bracket, E is for exponentiation, D is for division, M is for multiplication, A is for addition, S is for subtraction. All right, S is for subtraction. Okay, before I proceed, can you still hear me? If you can still hear me, say I can still hear you, sir. Say I can still hear you. If you can still hear, so you can proceed. Because sometimes network can actually fluctuate, that I would feel that you can hear me, but maybe there become a disruption in the connection. So if you can still hear me, say I can still hear you. All right, beautiful. All right, so there are people who can still hear me. Nice. So these are the arithmetic operators. Like I said, we have bracket, exponentiation, we have division, we have multiplication, addition, and subtraction, which has the acronym BEDMAS. So basically, this is the order of precedence. It's not based on anyone you can remember. It's not. Bracket follows before exponent, just like BODMAS. Okay, just like BODMAS that we know, in mathematics. Bracket comes before open them, division, multiplication, addition, and subtraction. But this one is what? BEDMAS. Okay, this one is BEDMAS, used in computer programming. Okay, so bracket has to be executed first before exponentiation, before division, before multiplication, before addition. So this is the precedence, order of precedence. Okay, so for instance, now if we have, let's say we have A plus or let's say A minus B plus C asterisk D. All right, so now if you look at this, now the operators here are subtraction, minus, plus, and what? Multiplication. All right, so these are the operators. Then now, what are these letters? These letters are called operands. They are called operands. Okay, so they are called operands. So the variables are called operands, while the symbols, they are called operators. Now let me tell you this. Now you see this asterisk. Look at how it's written. For instance, now they are, like I say, asterisk multiplication. If you want to write the formula for force now, instead of saying F is equal to, if it's equals to M times A, that is mass times acceleration, what we say is that F is equal to what? M, then asterisk up, asterisk, then what? A. So this asterisk has to be what? At the top. It will not be down. You don't use times. The computer will not understand. What your computer understands is asterisk. Now, if you want to write another formula, let's say a formula that has square. Okay, let's say for instance now we want to say P is equals to AB squared. Now this will be written as P equals to, AB means A times B, A asterisk B, A times B, then asterisk what? Asterisk what? 2. This asterisk means exponential 2, that is raised to power 2. So if you look at this now, you realize that what the asterisks are at the top. You don't write the asterisks down. AB means A times B. Squared means B asterisk 2. So this is how we represent it. All right. So it's very important to note that. I'll be giving lots of examples, because you see arithmetic operators. Arithmetic operators are the most common operators. They are the most common operators. They are the most commonly used operators when it comes to formula translation. They are the most commonly used. All right. So moving forward, we'll be looking at the second class of operators, which we call logical operators. Logical operators. Now, these logical operators are also known as relational operators. Relational operators. That's what they are also known as. Relational operators. Okay. So what are these logical operators? So these logical operators uses actions that tends to be logical in nature. Okay, actions that relates formulas with each other or variables with each other. All right. So like I did for arithmetic operators, that I created something like I also say operators here. Then I'll write the actions here, the actions that they perform. So the first operator here is less than sign. If you look at this sign, is less than. So we say less than. This is the first operator, less than. Then the next one is less than or equal to. Less than or equal to. All right. Then the next one is the greater than. Next one is greater than. That's the third one. Okay. Then the fourth one is greater than or equal to. We have greater than or equal to. Okay. Then we also have equal to. Now the equal to is double. Equal to is double. Like double equal to is not just one, it's double. So that's how equal to is in Fortran. That is when you're using it as a logical operator, not when you're using it with arithmetic operators. When you're using it with arithmetic operators, it's just one equal to. But when you're using it with logical operators, it's double equal to. Take note of that too. Then we also have the dot or. We also have dot or. This is also called logical or. Logical or. That's the action that it performs. We have dot and. We have dot and. Dot and is called logical and. All right. We also have true. We have false. Okay, logical operators are actually more than arithmetic operators. But like I said, the arithmetic operators are the ones that are commonly used in Fortran. All right, the arithmetic operators are the ones that are commonly used in Fortran. Okay. We also, I think, yes, let me just add this one. Where I think we have dot not, which is also called logical nots. Okay, logical nots. All right. So basically I'll be giving you an example of these logical operators, like example of when they are used. Okay. For instance, now if we have a statement like this, say if bracket open a is greater than or equal to 5 or equals to 5 and a is less than 10, okay, then okay, so then what happens now when you have an operator like this? When you have an operator like this, what you have to do is to interpret it. When you're given an operator like this, what you have to do is to interpret it. Now you interpret it with respect to a. You interpret it with respect to the operand. Like I told you that these variables are called operands. All right. If you look at the operators that are here, we have greater than and equals or equal to. We have the logical and. Okay. We have less than. Okay, we have less than. So basically, if you have an operator statement like this, what you have to do is to what is to represent it in a way that will look like an interpretation. So, like I said, you have to interpret it with respect to the operand. So now it means that if A is greater than or equal to 5, if A is greater than or equal to 5, and A is less than 10, it means that A lies between what? 5 and 9. That's what it means. It means that A, that is the operand A, lies between 5 and 9. That's what it means. Okay? Because you say A is greater than or equal to 5. It means that A starts from 5, A starts from 5, 6, 7, 8. Then you have to, when you're writing, you have to consider where it stops. The A is less than 10, which means that A does not get to 10. So it's 5, 6, 7, 8, 9. If you remember your algebra and trigonometry, okay, we call these boundaries on the number line. Okay, so it means that A is bounded between 5 and 9. A does not get to 10, and A is not less than 5. A is greater than or equal to 5 and less than 10. So when you are now writing a statement to interpret this, you must interpret it with respect to what? With respect to A. So that's the idea. That's the idea. Okay, so that's an example. So we'll be looking at the one that is commonly used, like I said, the one that is commonly used and the one that you face more in exam conditions is the arithmetic operators. All right, so we'll be looking at more examples. So now let's look at another example. Let's say number one say A is equals to 4 over 5. All right, how do we translate this? This is very simple. Say A is equals to 4/5. We use slash. All right, we don't do it like this. We don't say 4. No, we don't do it like that. We don't carry 4 up and bring 5. No, we don't do that. It must be linear. It must be on the same line. So this is wrong. All right, this is wrong. This is how it should be represented. All right, this is how it should be represented. Okay, so so that's it basically. So the division sign is represented with a forward slash. This is called a forward slash. Now if we have, let's say let's look at number 2 example. We have the formula for area of a triangle, all right, where A is equals to half BH. A is equals to half BH. All right, I believe we are familiar with this formula. All right, so how do we translate it? This is very simple. So A will be equals to 1/2, okay, then asterisk B asterisk H. Simple. 1/2 is representing half times B times H. That's how we translate. That's how this is what the computer will understand. Okay, it's very wrong to say like this, then times B times H. Yes, in real sense, this is not wrong in real sense, mathematical sense. Okay, this is not wrong. But you see, for the Fortran compiler, that is the computer program, to actually understand, it will not understand this. This is what it would understand. Because what you're using operators in this context. All right, so now let's look at number 3, another one. Let's say area of a trapezium. Let's say A is equals to half A plus B then H. All right, so how do we translate this? This is simple. So we say A is equals to 1/2, then asterisk bracket open A plus B, close the bracket, asterisk what? H. Simple. All right, so like I said, you don't do slash. You don't do your slash like this. You don't leave it like this. It must be linear. Don't make 1 to be up and 2 to be down. No, don't do it like that. It must be linear. It must be in a straight line. All right, it must be in a straight line. So that's we'll be doing several examples as we are progressing. I'll be ensuring that I'm giving you more difficult examples. All right, more difficult examples. So now let's look at the formula for simple interest that we all know, that is principal times rate times time all over 100. We know this formula now from secondary school. So how do we translate this? This is very simple. So we translate this by saying I is equal to P asterisk R asterisk T, then slash what? 100. Slash 100. All right, slash 100. So basically it's important that we also put this in a bracket. We also bracket this. Do you know why we have to bracket this? Okay, the reason why we have to bracket this is so that okay, normally division occurs first, right? From bed mass, division occurs first before multiplication, right? So it does not really matter. Okay, it does not really matter, but it matters in the sense that T can divide 100 first. Okay, but T can divide 100 first before P and R even multiplies it, which is wrong. If T divides 100, because from the expression D comes first before multiplication. So you have to bracket it. So when you bracket it, before you open the bracket, it must have multiplied first for you to get one entity. For instance now, if P is equals to 10 and R is equals to 2 and T is equals to 6, your principal 10, rate 2, T 6. Normally, you're supposed to have something like this: 10 times 2 times 6, right? Divided by what? 100. Okay? Divided by 100. But now, if you don't put it in bracket, this in bracket, now I'm just using the normal sign, so, but if you don't put this in bracket, now this will look like 10 times 2 times 6 all over 100, right? So what will happen? What will happen is that it will now be 10 times 2, then times 6 over 100. This is what you may face. And now you end up now dividing 6 by 100 before you say 10 times 2. 6 over 100 is what? 0.06, which is entirely what? Entirely wrong. But now, if you have this in brackets, you have 10 asterisk 2 asterisk 6, then slash 100. What will happen? For this bracket to open, all of them needs to multiply themselves, right? 10 times 2 is what? 20. 20 times 6 is what? 120. So as this bracket is opening, you have only one entity, and 120 will divide by what? 100. That will give you what? 1.2. I'll give you 1.2. So it's important that when you have more than one entity like this, ensure you put all of them in bracket when you before you divide. So it will show that it is everything that is here that is what dividing what you are actually using as the dividend, not just one entity inside. All right. So I believe that is clear, right? So now let's look at the fifth example. Okay, now let's say we have V equals to U plus 80. I believe we are familiar with this. This is one of the equations of motion, right? And so what do we say? This one is simple. Say V will now be equals to U plus A what? Asterisk what? T. Okay, A asterisk T. Now, in this case now, do you know why you don't need to put this in brackets? Because multiplication happens before addition. So this will definitely multiply. It will not be U plus A then times T. It will not be like this. This will not even happen. This will not happen. So there is no need putting this in bracket because multiplication will be implemented before addition. So now if you have A, let's say A to be 20 and T to be 5. Let's say acceleration is 20 meters per second squared, and your time is 5 seconds. All right, and let's say your u is let's say 4 meters per second. U is velocity. Okay, now what do you do in this case? Now you see this expression. That we have u plus a times t. It will definitely be like this. We have 4 plus, what is a is 20, right? 20 times 5, because multiplication comes first before addition. What will happen? This will multiply, so this will be 4 plus what? 20 times 5 is 100, right? 100. This will give you, then now 4 plus 100, that's what will give you 104. So you don't necessarily need to put these brackets. So you only put bracket in cases where you know that the precedence supports. That's where you put bracket. Okay, you put bracket, because when you say precedence support, it means that one would be implemented before the other. All right, division will be implemented before multiplication. That is why anything you're multiplying, you must put it in brackets. But look at multiplication will be implemented before addition. So when anything you're multiplying, you don't really necessarily need to put it in bracket, because they will multiply first before they add. That's the idea. That's the concept. All right, that's the concept. I believe you can still hear me. Can you still hear me? If you can still hear me, say I can hear you, sir. So I can proceed. If you can still hear me, type I can hear you. I can hear you, sir. If you can hear me, say I can hear you. Please, it's not really going to be a big deal to type I can hear you, so I would know, because like I said, network sometimes can be a problem, and I can be teaching and I wouldn't know that I'm teaching myself and no one is hearing me. So I need to be sure that the network is still stable, that you can hear me. So I need more responses. Please, I need more responses quickly. All right, nice one. Okay, so Imakul, Chukunyere, Mesomachi, Success Ndubisi, I've seen your responses. All right, you can hear me, good. So let's proceed quickly. Now this is the fifth example. We'll be looking at more examples, so we'll be getting it clearer. All right, okay, Debbie's, I can see Doregbara Kaduto, I can see yours as well. Good, nice one, you can hear me. All right, so now let's proceed. Number 6. Now let's look at another equation of motion that we are familiar with. S is equals to ut plus half at squared. All right, so how do we implement this? How do we implement this? Now let me say this. You can see squared here, right? You can see squared here. Okay, you can see squared here. Now basically I want you to understand that this square you're seeing here can also be cube. It's not just squared. But when we are using asterisks, for instance, now we have t squared. T squared is t asterisk, right? Then 2. That's what t squared is. T cube will be t asterisk, what? 3. Not t asterisk, 3. Wrong. So the asterisk is always 2. What would only show the difference is the number you write. So if the number you write is 2, it means that t is being raised to power 2. If the number you write is 3, it means that t is being raised to power 3. That's what it implies. That's what it implies. All right, that's what it implies. So now let's do this one. So S is equals to ut plus half at squared. So what do we say? So S now, because ut now will be u asterisk t now plus 1/2. Remember that this forward slash is used for what? It's used for division. Then we say asterisk again. Then asterisk what? A, that is times A. then asterisk again, t asterisk asterisk what 2. All right, t asterisk asterisk 2. So basically, if you look at this now, you realize something. You realize that this t here, this t asterisk asterisk 2 is exponentiation, and in this entire equation e comes first. So this exponential would be executed first, because asterisk asterisk is higher than any other operator in the formula, then followed by what? Division. Followed by division, then lastly what? Your multiplication. Lastly your multiplication. Okay, then of course, okay, we have plus here, then positive. After multiplication, now will be positive. Okay, so it's important to note that. Now, so basically, like I said, exponentiation would be implemented first. Okay, exponentiation will be implemented first. Now, usually it's good to put exponentials. It's not like it's going to really be an issue, but it's good to put exponentials like this in brackets. Express them in brackets. All right, express them in brackets. Okay, so it's not like there's any special thing, but just express it in bracket. Okay, so like I said, this one will be implemented first. Once it's implemented, now a will multiply what you have. All right, but now before a will even multiply, this has to be divided. 1 will divide 2, so we have 0.5. So 0.5 now will now multiply a will multiply this. In fact, you will also multiply t. Then the last thing you will now have will be your positive sign. That is the last thing that will be implemented. If we must follow this this precedence, this order of precedence, which is bed mass. All right, if we must follow that order of precedence, which is bed mass. Okay, so that's the point. Okay, now let me just give you an instance. Now let's say u is 2, let's say t is 5, and a is 4. All right, let's say these are the values. Okay, now this is how the compiler will calculate. Now first of all, this is what the compiler will do. Excuse me. Now the compiler will say, now s is equals to 2. Remember, u is 2, right? So the compiler will calculate it 2 asterisk 5 plus 1/2 asterisk 1/2 asterisk 4 asterisk what 5 asterisk what 2. Okay, so the compiler will calculate it like this. The compiler will calculate it like this. So now the first thing, after arranging it like this, what the compiler will do next is that the compiler will say s is equals to 2 asterisk 5 plus 1/2 asterisk 4 asterisk bracket will open 5 asterisk 2 is what 25. 5 asterisk 2 is for like 5 squared, 5 times 5. Then after remember I told you exponentiation was the first thing that will be done, right? Then after the exponentiation, the next thing that will be done is your division. So it means that s now will be 2 asterisk 5 plus 0.5 asterisk 4 asterisk what 25. Then after division has been executed, now the next thing will be multiplication. 2 asterisk 5 is 10, right? Plus what? 0.5 asterisk 4 asterisk 25 is what? That is 0.5 times 4 times 25 will give you, I think, will give you 50, because half of 4 is 2. Half of 4 is 2. Then 2 times 25 is 50. Okay, then the last thing is s. Now with 10 plus 50 will give you what? 60. All right, so this is the particular order. This is the particular order that will be followed to execute this formula when you have these values. When you have these values. Okay, here you have these values. So it follows what? Bed mass strictly. Follows bed mass strictly. Follows bed mass strictly. All right, so I would exhaust as many examples that I have for you. I'll exhaust as many examples I have for you, so you will not find anything confusing. You will not find anything confusing when you actually see formulas, okay? When you actually see formulas to translate, okay? All right. So let me quickly get, because the other paper is full, let me quickly get another paper so we'll proceed immediately. All right. Now someone is asking, are you going to solve anything in exam? Now this is CBT. This is a computer-based test. This is CBT exam rather. So basically, you should be able to like have knowledge of formula translation, because when you have something like, you can be given options. All right, I would say using formula translation like the one I just did, like the one I did here. Okay, so using formula translation, giving these values, okay, translate, okay, translate, or they can say which of the following is the correct translation for this, okay? Or even if it is it may not necessarily be obj or true, it may not necessarily be objective or true. You can also give space where you have to like type in this translation. What I'm saying is that if you're now translating it, you're now writing the translation of this, don't be using multiplication. Use, there's asterisks in the keyboard, okay? Don't be using multiplication, don't use the over, use slash, forward slash to represent division, okay? All right, so we are back. So now let's proceed with more examples, okay? Let's proceed with more examples. Okay. All right, so the last one we treated, that was example 6. That was example 6. So now let's look at another example. This one is a little bit dicey. All right, so now let's say P is equals to square root of S bracket S minus A, close the bracket, S minus B, close the bracket, then S minus C. All right, so we are given something like this kind of expression. How do we translate this in Fortran? How do we translate this in Fortran? All right, so it's simple. Okay, so first of all, I want to introduce something. Look at square root. Square root is expressed as SQRT. SQRT. Okay, SQRT. Now if we have, let's say, cube root, it will be SQRT3. That is square root. There is no, you will not put anything in bracket. If it is quatic root, SQRT4. If it's a fifth root, SQRT5. All right, SQRT5. So that's how we represent square roots. Okay, that's how we represent square root. But now most times, in fact most times you will not see, the Fortran compiler may struggle to represent this. Fortran compiler may struggle to represent this. The Fortran compiler most times is only familiar with the square root, that is one that has a root 2. So, and other time, in fact, the ones that are generally used now, if we have a cube root, so you do something like this. You say asterisk 1/3. Okay, for instance, now let's say you have cube root of t. So this, the best way to actually do for cube root now, you say t asterisk 1/3. T asterisk asterisk what? 1/3. Okay, so now you have to put this in brackets. The reason why you have to put this in brackets is because in BEDMAS, exponentiation tends to be more implemented first. So because exponentiation is implemented first, you need to divide 1 by 3 first. All right, you need to divide 1 by 3, because as you're opening the bracket, the execution will be happening inside the bracket. If this is quartic root, let's say quartic root of let's say A, it will be written like this: A asterisk asterisk bracket 1/4. Okay, this is how we do it. So instead of this, it's not as if this is wrong, but don't use this. So when it comes to square root, you can only use SQRT for square roots. Like when we say square root of t now, it will just be SQRT bracket what? T. SQRT bracket T. Okay, I believe this is clear. Then anything like cube root and above, then you can make use of this. Okay, you can make use of this. If it is if it is the fifth root, if it is the fifth root of A, for instance, now you say A asterisk asterisk 1/5. Okay, 1/5. Remember, asterisk must be at the top. Don't forget that. So now let's come back to this. Let's translate this. So now basically translating this, we'll say P is equal to, first of all, the square root comes. All right, the square root comes first. So this will be SQRT, then what? Then brackets S multiplies S minus A, also multiplies, then okay, S multiplies S minus A, then after S minus B, then S minus C. Okay, from this, it means that we'll open a bracket, say S, then multiplication is asterisk bracket S minus A, close the bracket. There is multiplication here again, multiply, that is asterisk, open X minus B, close the bracket, then another asterisk, S minus C in brackets. Then this bracket, now you have to close it, so you close the bigger bracket. So this is how it is expressed. This is basically how it is expressed. Now you can also express this in this form. You can say S asterisk S minus A asterisk X minus B asterisk X minus C, close the bracket, close the bigger bracket, asterisk asterisk 1/2. I say 1/2. You can also represent it like this. Okay, but you see this SQRT. The SQRT is designed specifically for square roots. For square roots of 2. Like I said, anyone that is more than, instead of using this, use this 1/1/3, 1/4. 1/2 still works for square root of 2. That's why I said it can also be represented as this. Okay, all right. So okay, now let's just take for instance now. Okay, let's look at another example. Let's say number 8. Let's say we have square root of A plus D in brackets, then raised to power 3. Now this is a power that is inside what? A root. So how do we represent this? Now we say SQRT brackets, okay, bracket, then we have another bracket inside. Remember, anytime you put SQRT, you must open a bracket. Anytime you put square root, you must open a bracket. But we have another bracket here. That's why I put in another bracket. Then you have A plus D. Close the bracket. Then as you can see, there is a cube here, right? There's a cube here. So when you close the bracket, this A plus D is raised to power 3. So you say asterisk asterisk what? 3. Then what? You close the bigger brackets. Simple. Is this bracket that closes here? The brackets, you don't just pack brackets. The brackets must be equal. Okay, the brackets must be equal. Open, close, open, close. All right. Now let's say you have another example. Let's say you have cube root of d. You have cube root of d. This is very simple. Like I said, this will just be your d, then what? Asterisk, what? 1/3. Simple. All right. Now let us translate almighty formula. That is the quadratic formula. Remember, quadratic formula is x is equals to minus b plus or minus b squared minus 4ac, right? Then all divided by 2a. All right. This is the quadratic formula. So now if you look at this, we have both plus and minus. So it means that we will have two formulas from here. That is the plus and the minus. Now let's do the plus first. So now let's call the plus x1 equal to. So now let's do the plus first. So this will be open a bracket minus b plus, there's a square root here, so we say sqrt, right? Then inside the square root we have b squared. So b squared is b asterisk 2, then minus 4 ac means 4 times ac, right? So this will be 4 asterisk a asterisk what? C. Then what? Close the bracket. You know, this bracket you close is for this one. How about this one? Close the bigger one, because everything here is what is dividing 2a. So close everything here, then you divide it by 2a. How do you do that? Now you divide, you say slash 2 what? Asterisk what? A. Finish. 2 asterisk a. Okay, 2 asterisk a. So it's important to actually understand that okay, now at this point now you have to put this in bracket. Do you know why you're putting this in bracket? Because among everything here, after exponentiation is division. So you don't want to find yourself in a situation whereby everything here will divide 2 before now multiplying a. They are dividing both 2 and a. So that's why it's important to put this in bracket as well. All right. Then of course your x2 will still be like this, but the only difference is that this will now be minus. So you will now have minus b minus what? Square root of b asterisk 2 minus 4 asterisk a asterisk was c, close, then slash what? 2 asterisk what? A. All right, that's asterisk a. So that's how to translate. All right, so I'll be giving you some exercises. I want you to try these exercises on your own. Okay, try these exercises on your own. So you'll be translating these formulas for me. Now number one, we have a equals to p bracket 1 plus arrow all over n, then raised to power nt. Okay, that's number one. Number two, we have r equals to abc all divided by square root of 4s bracket s minus a, s minus b, s minus c. Okay, so this is the second one. Then the last but not the least, the third one you would try for me would be let's say f. Let me give you electrostatic force formula. F is equals to that formula k q1 q2 all over r squared. This one is simple now. K q1 q2 all over r squared. So try this. Okay, try this. So in our next class, which may be today or tomorrow, okay, we'll be looking at some other concepts. All right, we'll be looking at some other concepts. And if you want to reach me on via WhatsApp, this is my WhatsApp contact 081 4090 6243. All right, so I'll be conducting a CBT mock exam on the registered platform tonight. So if you want to get registered, okay, if you want to register for this mock exam, just send me a message on WhatsApp. All right, so I'll add you to the WhatsApp group. All right, so you can be a part of this mock exam. Okay, so that's it basically. All right, so if you're not subscribed to this channel, hit the subscribe button. Like I said, we'll be having another live class. Okay, in that live class we'll be talking about other concepts that you need to know. All right, we'll be talking about basic input and output statements. We'll be talking about how to write simple programs, and of course the program structure in Fortran. We'll also talk about arrays. We'll talk about control structures. All right, control structures. I'll teach you how to write simple programs. All right, so like I said, we may have that class later today. We have about 2 classes because one class will not be able to cover this. All right, so I think this is where we'll draw the curtain. I believe you can see this, right? Have you been able to copy this? If you've written this down, please write I have written it. If you've written this exercise, so you can send your answers to me on WhatsApp. All right, send your answers to me on WhatsApp whenever you're done. If you can see, if you've been able to write this exercise down, say I have written this exercise, I've written it down. Let me be sure that everyone have seen it. Okay, good. I can see your responses. Please, this F, this F, which stands for force. K, Q1, Q2 all over R squared. R, A, B, C. There's a square root here. Okay, the square root that covers here. Okay, then this is 1 plus R over N raised to power NT. Okay, so all right, so this is what we call, like I said, this is what we call it today. All right, so subscribe to this channel if you have not subscribed, and see you in the next live class. Ensure you do this exercise and send it to this WhatsApp number if you want to participate in the mock exam tonight. Also, let me know that you're interested, and I will tell you the registration information and you'll be a part of it. Okay, so you're also welcome. You're welcome. All right, so thank you as well for being a part of this class, and take care. Have a nice day. Enjoy the rest of your day. Bye.